Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram, PU College. My dear students, in today's session, I will be discussing very important topics, very crucial topics, exam-oriented topics. We shall understand the meaning of something called electric flux. We shall understand the definition of surface density of charges, linear density of charges, and with aid of all these concepts, I will discuss a very key theorem, something called Gauss Law of Electrostatics. Many a times, frequently asked in the examination for 1 mark as well as a 5 mark based on its application. So now, just to have a recap, a review of things we did in my previous session, we stopped discussing something called torque acting on a dipole, where we wrote tau equals PE sin theta. So this is the expression for torque we mentioned. Tau, torque equals PE sin theta. What was P? It was the magnitude of the dipole moment. What was E? It was the strength of the electric field. And what was theta? Angle between dipole moment and electric field. And we also mentioned under what conditions torque becomes minimum and maximum. What was the condition for torque to become minimum? We told either theta has to be 0 degrees or 180 degrees, which means if dipole moment is parallel or anti-parallel to the direction of the electric field. And when was the dipole maximum, torque maximum? It was when theta is 90 degrees. That is when dipole moment was perpendicular to the direction of the electric field. Now, continuing my discussion, a very important concept. Again, I can say a featured concept to understand Gauss law and its applications, what we call as electric flux. Gauss law ಮೇಲೆ based ಆಗಿರುವ 3 applicationಗಳಲ್ಲಿ electric flux na ನಾವು ಉಪಯೋಗಿಸ್ಕೊಳ್ತೀವಿ. So it is a very important term for us to understand, which is denoted by the symbol PHI, what I call as phi. So electric flux denoted by the symbol phi, PHI. Now let us initially understand the textual meaning, the linguistic meaning of this word flux. Then we understand electric flux. ಮೊದಲನೇದಾಗಿ ಫ್ಲಕ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. ವಾಟರ್ ಫ್ಲಕ್ಸ್ you have studied in your first PU. Dear students, no exaggerations. In simple terms, The word flux refers to density. Ashte. Bere yav exaggerations illa. Flux means density. And now remember, density here I refer as some number. Density here I remember it is a number. Flux density. Density of tigers in India. Andreno, number of tigers present in India. Density of people in Mysore. Number of people staying in Mysore. So at this point of time, I just want you all to understand that the word flux relates to density, and here I have called density as some number. So with this, I try to understand what is electric flux. So something that has to be related with electric field. So I consider a surface of the electric field what I call as S. What is S? It is the surface of the electric field. So very clearly I have told, let S be the surface of the electric field. Some electric field. ಈಗ ಏನ್ ಮಾಡ್ತೀನಂದ್ರೆ I will resolve the entire surface into smaller region. I will cut the electric field into smaller parts, where each part I say has an area what I call as ds. So ds refers to smaller regions. So ಏನು ಮಾಡಿದ್ದೀನಿ? I had a surface of the electric field. I have broken down the electric field. I have resolved the electric field into smaller regions, smaller parts. And what do I call those smaller regions as? ಒಂದು ಚಿಕ್ಕ region, ಚಿಕ್ಕ part ನ ಏನಂತ ಕರಿತೀವಿ? Generally element. Here ds is referred as surface element. Please do keep in mind ds surface element, small region, small part of the electric field what I call as S. So very clearly I have told elements, each of area ds. So what did I do, my friends? There was an electric field, yes. I have broken down the electric field into small regions, small parts, and I called each part as surface element. And what was the area of the surface element? ds, smaller regions, smaller parts. Now, I am considering one such surface element, one such smaller region ds, and if this is the ds, I draw this as the direction of the electric field. So this gives me the direction of the electric field. So I have considered one surface element whose area is ds. The electric field acts tangential to the surface. And what have I done? I have drawn a normal to the surface ds. I repeat, my students, the electric field is acting tangential to the surface ds. Why tangential? Clearly next chapter describes. Now just know electric field is tangential to ds, and I have drawn a normal to the surface. Now, what is this angle theta? It is the angle between the electric field and the normal. Clear ಆಗಿ ನೀವು ಡಯಾಗ್ರಾಮ್ ನ ಅನಲೈಸ್ ಮಾಡಿದ್ರೆ theta is the angle between the electric field and the normal. ಅಲ್ಲೇನೋ ಒಂದು ಈ ಕಾಸ್ ಥೀಟಾ ಅಂತ ಬರ್ದಿದ್ದೀನಿ. ಪ್ಲೀಸ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಐ ಹ್ಯಾವ್ ರಿಟನ್ ಸಮಥಿಂಗ್ ಆಸ್ ಇ ಕಾಸ್ ಥೀಟಾ. ವಾಟ್ ಇಸ್ ದಿಸ್ ಇ ಕಾಸ್ ಥೀಟಾ? As the description says, it is the component of intensity along the normal. Electric field strength we also call electric intensity. Normal is also treated as horizontal. And in first PUC, you have studied resolutions, projectile chapter. So along the horizontal, with reference to theta, we always write cos theta. So what is the component of intensity along the normal? It has to be E cos theta. So what is important for me to remember here? First, surface element. What is its area? ds. What is E? Strength of the electric field. What is theta? Angle between the electric field and the normal drawn. And very, very important, what is cos theta? E cos theta, component of electric intensity. Nothing but the electric field which is acting along the normal. I repeat, E cos theta is a part of this field, part of this intensity which is acting along the normal. Then, what is the electric flux that is related with the surface ds? Very simple. The mathematical definition says, kindly highlight here, d phi electric flux across the surface ds. d phi equals E cos theta into ds, product. So very simple, electric flux is a product of what? E cos theta into ds. So what is E cos theta? Component of electric intensity along the normal. What is ds? Area of the surface element. What is its product called? That itself is called as electric flux. So my dear students, ಪರೀಕ್ಷೆನಲ್ಲಿ ಒಂದು ಅಂಕಕ್ಕೆ ಯಾವಾಗಲೂ ಕೇಳ್ತಾರೆ, write an expression for electric flux in terms of intensity and area. What is the intensity here? E cos theta. What is the area? ds. And that product is what we call as electric flux. So keep in mind, wherever I do applications on Gauss theorem, Wherever I calculate electric flux, it is given by the expression E cos theta into ds. Andre, flux due to one element is E cos theta into ds. Flux due to the second element, ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಒನ್ ಮೋರ್ ಇ ಕಾಸ್ ಥೀಟಾ ಇಂಟು ಡಿ ಎಸ್. ಇನ್ನೊಂದು ಎಲಿಮೆಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇ ಕಾಸ್ ಥೀಟಾ ಇಂಟು ಡಿ ಎಸ್. ಸೊ ವಾಟ್ ವಿಲ್ ಬಿ ದ ಫ್ಲಕ್ಸ್ ಅಕ್ರಾಸ್ ದಿ ಎಂಟೈರ್ ಸರ್ಫೇಸ್? It has to be the summation of E cos theta into ds. Therefore, here my simplest understanding is the definition of electric flux. What is electric flux? Product of component of electric intensity E cos theta into the area of the element, which is ds. Now, ಮೇಷ್ಟ್ರು ಇನಿಷಿಯಲಿ ಫ್ಲಕ್ಸ್ ಅಂದ್ರೆ ಡೆನ್ಸಿಟಿ ಅಂತ ಹೇಳಿದ್ರು, ಅದೇನೋ ನಂಬರ್ ಅಂತ ಹೇಳಿದ್ರು. ಇಲ್ಲಿ ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಡೆಫಿನೇಷನ್ಸ್ ಬಂದಿದೆ. ಹಾಗಾದ್ರೆ ಸಿಂಪಲ್ ಆಗಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂದ್ರೇನು? ವಾಟ್ ಈಸ್ ದ ಸಿಂಪ್ಲೆಸ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್? ಇಟ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್. Suppose I have considered an electric field. The number of electric field lines passing normally through this field itself is called flux. ಏನು ತುಂಬಾ ಹೈಯರ್ ಆರ್ಡರ್ ಥಿಂಕಿಂಗ್ ಅಲ್ಲ. ಫ್ಲಕ್ಸ್ ಅಂದ್ರೆ ಡೆನ್ಸಿಟಿ ಅಂತ ಹೇಳಿದೆ. ಡೆನ್ಸಿಟಿ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ where passing normally through any electric field itself is called electric flux. So mathematical definition says electric flux is E cos theta into ds. Intensity into area. Physical meaning ಏನು? Number of electric field lines which pass normally through a surface. ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮೂಲಕ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಪಾಸ್ ಆಗುತ್ತೆ ಅದನ್ನೇ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Now, I need to write the SI unit for electric flux. The first one marker in your 2020 PU exam, write the SI unit for electric flux. So that is equal to, you'll gamansi, unit for electric flux. Mathematically, how have I defined? Flux equals E cos theta into ds. E cos theta andreno? It is the electric intensity. Basically, how did I write electric intensity? Force divided by charge. E equals F by Q. So intensity is force divided by charge into ds. What is ds? ds was nothing but area. So what is the SI unit of force? Newton divided by Coulomb. Coulomb inverse, area meter square. So in simple understanding, the SI unit of electric flux is Newton, Coulomb minus 1 meter square. So just remember, the summary of the entire description is electric flux d phi equals E cos theta into ds. What is this E cos theta? It is the intensity acting along the normal. What is ds? Area of the surface element considered. And physically, it is nothing but the lines of force which pass through the given area. Now, we study three very important definitions to understand Gauss law, because the geometry of the Gaussian surface considered depends upon the definitions here. The first definition is surface density of charges. ಪರೀಕ್ಷೆನಲ್ಲಿ ಒಂದು ಅಥವಾ ಎರಡು ಅಂಕಗಳಿಗೆ ಕೇಳೋ ಸಾಧ್ಯತೆ ಇದೆ. Probably for 1 or 2 marks. Surface density of charges represented by the symbol sigma. Now, I'll consider a conductor on which I will show the distribution of charges exactly as in the diagram. My dear students, if you observe the diagram, has it a regular geometry? Is it a circle? No. Can I call it a sphere? Absolutely no. Is it a prism? No. Therefore, what will I call? Irregular shaped conductor. Regular dimensions illa. It doesn't have regular geometry. Therefore, I call it as irregular shaped conductor. So what is the nature of distribution of charges? It is also irregular. So my conductor is not of regular shape. It is irregular in shape, indefinite in shape. Therefore, I call it irregular shaped conductor. Irregular shape ಆಗಿರೋದ್ರಿಂದ ಅದರ ಮೇಲೆ distribution of charges irregular ಆಗಿದೆ. Now, I consider the surface of the conductor. Some point O on the surface of the irregular shaped conductor. A conductor ಇದೆಯಲ್ವಾ, ಅದರ ಸರ್ಫೇಸ್ ಮೇಲೆ ಒಂದು ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. And I will consider unit area around that point. Unit area ಅಂದ್ರೆ 1 meter square area. ಆ ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ, ಅದರ ಸುತ್ತಲೂ ಯೂನಿಟ್ ಏರಿಯಾ 1 meter area I have considered. Simple in terms, the total number of charges present in this unit area around that point, that is what is called surface density. Mat puna nodi, density, number. Here it is number of charges present where? Unit area around a point where on the surface of a conductor. So we say surface density of charges at any point on the conductor, maybe on this point O, maybe on this point X, any point you consider on the conductor and refer to unit area around it, 1 meter square area around it. Total charges present there is called surface density. So mathematically we say surface density is total charge by total area. This is the word which will differentiate this from the other two definitions. total charge divided by total area. Nenpitಕೊಳ್ಳಿ, sigma. Surface density is always total charge divided by total area. So we write sigma is Q divided by A. This is very phenomenal for me to understand Gauss law. Sigma, surface density, is always total charge divided by total area. Now to write the SI unit of surface density, what is the unit of charge? Coulomb. Divided by area, meter square or meter minus 2. So the surface density has unit coulomb meter minus 2. So my dear friends, again to understand, sigma, which is surface density, is always total charge divided by total area, which means on the surface of a conductor anywhere, maybe uniform surface, non-uniform surface, consider a point. Then what will you consider? 1 meter square area around that. Total charges present there is what is called surface density. Now, watch the consequences here. If you observe the diagram where I told irregular shaped conductor, so charge distribution is irregular. But look at the nature of distribution. Wherever we have pointed ends, there are more charges present. And wherever there are bulged ends, there are less number of charges. So point 1, please do remember, charges accumulated more at the pointed or the sharp ends of a conductor. ಒಂದು ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಎಲ್ಲಿ ಶಾರ್ಪ್ ಎಂಡ್ಸ್ ಇರುತ್ತೆ, ಪಾಯಿಂಟೆಡ್ ಎಂಡ್ಸ್ ಇರುತ್ತೆ, ತುದಿಗಳಿರುತ್ತೆ, number of charges will be more. Wherever you have bulged ends, there will be less number of charges. This is important. Sigma. Sigma means surface density is directly proportional to the curvature of the surface. Very important. Surface density, number of charges are directly proportional to the curvature of the surface. Yenid curvature? Very simple to understand. Curvature andre sharpness athwa pointedness anta artha. If the end is more sharp, surface density will be more. Means to say there will be more charges distributed. And the same sigma is inversely proportional to the radius of the curvature. Yak radius? Radius is directly proportional to area. Area increases, bulgeness increases. So naturally, number of charges should decrease. So my dear friends, please to understand, surface density, number of charges, they are always proportional to the curvature of the surface. Wherever there are pointed ends, wherever there are sharp ends, more charges has to be present. And as the radius increases, bulgeness increases. Number of charges stored should be less, so sigma decreases. So very clearly, surface density, number of charges, maximum at pointed ends. Now, they're all like charges, which are accumulated at the sharp end. Like charges andmele repulsion irbekalva. So what should happen? Tudinal jaga kadme, pointed ends, less space, but more charges are accumulated. All the more they are repelling each other. So what should happen? They should start leaking to the surrounding medium. Yenak leak agutte? It is a sharp end. There are more number of charges. They are like charges. They are repelling each other. They are pushing each other. So what is the consequence? They will start leaking to the surrounding air. And that is what we call action at points. What action is happening at points? Leakage of charges. Charges start leaking to the surrounding medium. Why this leakage has happened? They are like charges. They are experiencing mutual repulsion because of small space. And that is what we call as action at points. Now, the next definition is linear density of charges represented by the symbol lambda. Linear. Yen linear andre somewhere straight anta artha. Remember, so linear density is a definition associated to linear conductors, straight conductors, in example of straight wires. Wherever I need to apply Gauss law with reference to straight conductors, linear conductors, my definition of linear density comes into picture. Very simple. What is lambda? What is linear density? It is nothing but total charge by total length. Vyathyasa nodi. Surface density, sigma, when I defined, it was total charge divided by total area. But when I define linear density, it is total charge divided by total length, dq by dl. And the concept is same. Straight wire I have considered. Small portion of that wire, small length of that wire, dl. Then the total number of charges appearing in the small length is what is called linear density. I am not considering the charge in the entire length. Maybe of complications. Munde infinite length ottira. A complication na avoid madlikke we define linear density. I have considered a small element, a small portion of this wire whose length is dl, and the total number of charges on this length is what we call linear density. And therefore, how did I define linear density? It is total charge divided by total length, dq divided by dl. So, again the SI unit of charge is coulomb, length is meter, area Allah. So coulomb, meter minus 1. I wanted you all to know this difference. So I have highlighted meter minus 1. So linear density, total charge by total length. Surface density, total charge by total area. And the third one, volume density, which is apparently used less in electrostatics, which is total charge by total volume. It is three-dimensional. So wherever we have electrodynamics, we go over to this concept. So please do highlight on surface density, total charge divided by total area, linear density, total charge divided by total length. Now, as a trivial part of the discussion on this chapter, a very defined concept called Gauss Law of Electrostatics. Gauss Law, a very favorite question for any question paper setter. Maybe statement of Gauss Law asked for 1 mark, and we do 3 applications on Gauss Law. One of the application for 5 marks is a sure question. Gauss Law of Electrostatics, because again in your magnetism you study Gauss Law of magnetism. No, this is for stationary charges. Gauss Law of Electrostatics. First, I will read the statement of Gauss Law. It says, total electric flux. Again, see, that is what I told. Gauss Law is stated with reference to electric flux, number of field lines which pass through a surface. Total electric flux across a closed surface. A key term I am using, closed surface, in vacuum, in a medium of free space. I am considering electric flux where across a closed surface. In which medium? Vacuum. Free space is equal to 1 by epsilon naught times epsilon naught. Al barudwala free space. 1 by epsilon naught times the total charges enclosed by the surface. So electric flux across a closed surface. In which medium? Vacuum. What is it equal to? 1 by epsilon naught times the total charges present on that surface. Now, my very first attempt is to understand what is a closed surface. Now, all of us have played with rubber balls. I take a rubber ball and cut it into 2 halves. So this is 1 half of the rubber ball and this is the other half. So a rubber ball which is cut into 2 halves. Can I not invert each half? ಪ್ರತಿಯೊಂದು ಭಾಗನೂ ಆ ರಬ್ಬರ್ ಬಾಲ್ದು ಫ್ಲಿಪ್ ಮಾಡಬಹುದು, ಇನ್ವರ್ಟ್ ಮಾಡಬಹುದು. If this is possible, it is an open surface, which means an open surface always has sharp ends. ಯಾವಾಗ ಒಂದು ಸರ್ಫೇಸ್ ಅನ್ನ ಇನ್ವರ್ಟ್ ಮಾಡಬಹುದು, once you can flip flop a surface, it is an open surface. But consider the ball as a whole, the entire one. I cannot flip-flop it. I cannot invert it, which means to say it doesn't have defined ends. And this is what I call as a closed surface. Sphere is a closed surface. Plane sheets, cylinders. So my dear students, just know if a surface cannot be inverted, cannot be flip-flopped. That is a closed surface. Two halves of a rubber ball, if you can flip-flop, invert, it becomes open surface. So the first part you understand, Gauss law is always applied for closed surface. So the electric flux across a closed surface, where in vacuum, is always equal to 1 by epsilon naught times the total charges enclosed by the surface. Now, this is a closed surface which contains charges plus Q1 minus Q2 plus Q3, etc. Charges can be positive as well as negative. So the surface contains charges plus Q1 minus Q2 plus Q3, etc. So by the statement of Gauss law, flux phi should be equal to what? 1 by epsilon naught times the total charges enclosed by this surface. So phi equals 1 by epsilon naught times plus Q1 minus Q2 plus Q3, etc. So if I summate this, I write phi equals 1 by epsilon naught times summation Q. What is this summation Q? It is the total charges enclosed by the surface. So what is electric flux equal to? 1 by epsilon naught times the total charges, and that is what is the statement of my Gauss law. So what is Gauss law? It says total electric flux where across any closed surface, in which medium? Vacuum, is equal to what? 1 by epsilon naught times the total charges enclosed by the surface. So mathematically, phi equals 1 by epsilon naught times summation Q. Now, charges which are outside the surface, do they contribute to electric flux over this surface? No. Only those charges which are present on the surface, they contribute to flux over that surface. And any closed surface to which we can apply Gauss law is what we call a Gaussian surface. So dear students, what is Gaussian surface? Any closed surface to which Gauss law is applied is what we call Gaussian surface. So just to recall, what were the things we studied? Electric flux, E cos theta into ds. Please to memorize this expression. Across any surface, E cos theta into ds is electric flux. Surface density is total charge divided by total area. And where do charges reside maximum? Sharp ends. Linear density, total charge divided by total length. And what does my statement of Gauss law says? Phi equals 1 by epsilon naught summation Q. Total electric flux across any closed surface in vacuum is 1 by epsilon naught times total charges enclosed by the surface. So I hope when I come back in the next session with applications of Gauss law, you would have thoroughly studied all these concepts done today. So have a nice time. Stay safe. Thank you.